Welcome to CARIOQA PMP. My name is Christine Fallet. I work at CNES, Centre National d'Études Spatiales, the French agency for space research, for the last 30 years. I currently coordinate the CARIOQA PMP project, which stands for Whole Atom Rubidium Interferometer in Orbit for Quantum Accelerometry Pathfinder Mission preparation. Let's discover what CARIOQA PMP is about.
The project focuses on adapting quantum gravimeters for space use. This groundbreaking technology is currently only employed on Earth for ground evolution studies. This initiative lays the groundwork for a Pathfinder mission to test a quantum accelerometer in orbit, setting the stage for advanced sensors to enhance Earth observation and climate change monitoring. CARIOQA PMP is a €17 million project funded by the EU's Horizon Europe program over 3 years, involving a consortium of 16 key EU space industry and academic figures from 5 countries. Led by the French and German space agencies, it aims to advance a pioneering quantum Pathfinder mission using our collective expertise in quantum technology and space missions. Now, to understand why it is relevant to measure gravity, and to better grasp the interest and stakes of adapting quantum gravimeters to space, let's have a look at some physics notions. According to gravitational laws, the ground mass distribution directly influences the Earth gravitational field. For instance, water doesn't have the same density than dry soil, and consequently the same gravitational attraction. Therefore, the measurement of the gravity is paramount to identify ground specificity that we cannot observe with naked eyes. Quantum sensors are breakthrough technology that will provide more accuracy than past and present space missions. This improvement will contribute to a global and repetitive remote sensing of mass changes in the Earth system, ocean, atmosphere, cryosphere, solid Earth, allowing the monitoring of related essential climate variables and help monitor geodynamics phenomena related to earthquakes, volcanic eruptions, and ice melts. The goal of the CARIOQA mission is to test the ability of a quantum sensor to measure acceleration in microgravity on a dedicated satellite platform. The level of sensitivity and accuracy of the instrument will be determined in orbit by probing the drag force acting on the satellite. The results of this characterization will enable to design and provide ultra-sensitive sensors for future scientific space missions, outperforming classical technologies by orders of magnitude. Let's have a look now at this promising technology, the quantum accelerometer, and how it functions. Rubidium atoms are first prepared from a vapor to form an ultra-cold sample using an atom chip. The atomic cloud is then moved away from the surface of the chip and collimated via magnetic lensing. Then the free-falling rubidium cloud successively interacts 3 times with a unique pair of retro-reflected Raman beams acting on matter waves as beam splitters or mirrors. This creates an interferometer that enables to perform absolute acceleration measurements using the atomic cloud as a test mass. The atomic population in each output port of the interferometer is then measured by 2 cameras, using fluorescence and absorption techniques. It enables to determine the output phase shift of the atom interferometer, which is then proportional to the acceleration. In space, we will benefit from the microgravity environment to increase the sensitivity and accuracy levels by orders of magnitude by manipulating the atoms over several seconds. The different components of this quantum accelerometer will be accommodated on the satellite. The atoms will be manipulated inside a physics package placed at the center of mass of the satellite. A laser system will provide the light to cool, interrogate, and detect the atoms. The quantum accelerometer will be surrounded by all the components necessary to operate the satellite. After the launch, the solar array is deployed, and the satellite will reach its orbit to achieve the acceleration measurements. CARIOQA is only the beginning of a long and fascinating journey towards the use of quantum sensors in space. More than a technological milestone, CARIOQA Mission paves the way for improved gravity missions following the successful GRACE missions, which provide essential climate variables and thus help us understanding and monitoring climate change.